In this video, we're going to take a look at the shooting logic for the pistol in our main blueprint. First we have the custom event, then the condition checking that our weapon will fire is not zero. Then we check if we have any ammo left in the clip. Let's see the variables for the pistol. Pistol UI, pistol damage, pistol inventory that represents whether we have the pistol in our inventory or not. This is used by the weapon selection logic. Pistol ammo clip for the ammo in the clip, clip size, and the ammo in the backpack. So, when we have no ammo left, we go to this section for the automatic reload and the auto switch weapons. First, we check if automatic reload is set to 1. This variable is also here in the list. Automatic reload, auto switch, and bazooka exclusion, they're here. And this is being changed by our menus in the options. So the condition checks the automatic reload is set to 1 and the ammo in the backpack is more than 0. If both of them are satisfied, then we go to pistol reload. If the automatic reload is set to 0, then we don't go to reload, or we have no ammo in the backpack. If one of those conditions is not satisfied, then we go to another branch for the auto switch, and we check if auto switch weapons is set to 1, and if we have 0 ammo left in the backpack. Because if we still have some ammo, we shouldn't change our weapon. Back to the branch, and if we have some ammo in the clip, then we go to the sequence of events. First of all, we are subtracting 1 from the ammo clip. First, we have to get our current value. We can drag it here, get, set. This is what's happening here. We get the value, subtract 1, and set the same value to this result. Then we set weapon will fire to 0 so that we don't get interrupted, as all of the rest of the events checks this. Pistol fire rate. The delay roughly equals to the animation and represents the fire rate for the pistol. And after we set weapon will fire back to 1 and the weapon is ready to fire again. Next, we have this branch that checks if the ammo clip is equal to 0. If we had only 1 bullet left, then after this we have 0. And in this case, we will go to shoot to empty animation applied to the pistol and the character arms. However, if the ammo in the clip is not 0, then we use regular shooting animation for the pistol. We can take a look at those animations. We can hit browse, or we go to content, weapons, pistol, animations, pistol shoot. This is our normal animation. And this is shoot to empty. As you can see, it ends with this state. Next, line trace by channel. Same as before, only this one is extended even further. Branch, checking if we hit something, and then we go to the logic for the headshot. In the break hit results, we get the bone name, and we check if the name equals to head, the literal name. We have to type it in, and it has to match the name of the bone. Let's take a look at one of our characters. Let's say the fire demon. The fire demon's physical body can be found in the mannequin folder, as it uses the standard mannequin. Character mesh. Fire demon mannequin physics asset. Here you can see the colliders associated with the bones. This collider. The bone name for this collider is head. So for this to work, all of your characters gotta have a bone named head and a collider associated with the bone. In case this condition is satisfied, we apply damage, and the base damage is pistol damage multiplied by 5. You can change this value, of course. However, if we hit any other bone, we apply standard damage. We check simulating physics. I don't think it is necessary to check it here, because most likely if what we hit got a head, most likely it's simulating physics. Then we add impulse at location. And here I'm using not the normal, but our vector, our forward vector from the first person camera. And you can multiply it by a different value to adjust the amount of impulse. Now that I think of it, this is a more correct way probably to add an impulse. Or maybe not. It depends. Both of those methods work well. And next we go to pistol hit FX. Mostly it's the same as before, with slight difference. The default response, the default output of the switch on physical surface goes to another decal for the bullet holes. We attach it to the component that we hit at the location where the hit happens. And we need to specify the rotation, and it is multiplied by -1. Otherwise, the normals are rendered in the wrong direction. The decal size depth is set to 5. Let's take a look at the mannequin physics asset again. We can see the colliders here, this surface here. This distance between the surface of the collider and the surface of the body has to be covered. So if we set it to 1, it'll be too short and it will not be projected on this surface. However, you might see some bleeding on the ground, for example. So it works best when we have the colliders follow the shape of the body in a more precise way. This can be adjusted under primitives. You can add additional shapes to follow the shape of the body, and then reduce this value to reduce the bleeding of the decals. Another option is to use convex collisions. Let's create a duplicate. This is our duplicate. And here in the asset menu, we can reset our asset and choose single convex hull. And this creates a much more precise shape automatically. However, some of the elements will require adjustments. Like here, this should be assigned to the head and not the neck. Like so. New body. Single convex hull. Select the neck and delete it. Oh yes, there it is. There's our head now. Yes, and here is our neck. Now it looks correct. So you can use this type of physical body to have more precise collisions. And this way you can decrease this value and decrease the bleeding of the tackles. To apply our newly created physical asset, we have to locate our skeletal mesh. Fire Demon, skeletal mesh. Open it, and here in the asset details, here we can use our newly created asset. Now we can check the results. As you can see, the headshots still work. However, the downside is that you can see that the model, when it simulates physics, get twisted in a weird way. Let's get back to the logic. Next is the reload logic. First of all, we check if weapon will fire is not 0, as always. Then we check if the ammo in the clip is less than the ammo clip size. Because if the ammo in the clip equals to the ammo to the clip size, it means we don't need to reload anything. Next, we check if we have any ammo in the backpack to reload with. Then there is a sequence of events. After a short delay, we need to spawn our empty clip. Let's take a quick look at it. This is the animation that we will be referring to. So during this animation, after 0.5 seconds, we have to spawn the empty clip. Let's see this animation. So roughly about 0.5. We should spawn an empty clip. The clip will be spawned at a socket location that is called pistol clip socket. So let's go to the skeleton. In case you have a different modal displayed, the modal can be set here in this menu, as all of the weapons share the same skeleton. Here we can see the bones for all of our weapons. And here we can find pistol clip socket attached to pistol clip bone. So in the animation, we can set to display the bones, and you will see that here is our bone and there is our socket as well. And this is where the clip will be spawned. And you have to name the socket literally without mistake. So we set weapon will fire to 0. We play this animation. We play the sound attached. And after the delay that roughly matches the entire animation, we go to the logic of subtracting and adding the ammo. I have separated this logic into two parts. The first case is here, is when the ammo in the backpack that we have is less than what we need to refill our clip entirely. So here you can see ammo clip size minus the ammo in the clip that we currently have. This represents the amount that we need to reload. So the ammo clip size is set to 17. And let's say we shot 2 rounds. So we need to refill 2 rounds. And in case in the backpack we only have 1 round, then we go to this logic, this part of the logic. In this part of the logic, we add to the ammo in the clip the ammo in the backpack. Since we have less than enough to refill everything, we can simply add all of the ammo that we had in the backpack to the ammo in the clip. After that, we set the ammo in the backpack to 0, obviously, because we had less than enough. So we will use all of what we have to refill our clip. The other case is when we have more than enough. In this case, we subtract from the ammo in the backpack the amount that we needed to reload and set the ammo in the backpack to the result. And then we set the ammo in the clip to equal the ammo clip size, because since we had more than enough, we will refill our clip entirely. After this is done, we set weapon will fire back to 1, and our weapon is ready to fire or switched to another weapon. One thing I forgot. This part of the logic here, we spawn the muzzle flash. The muzzle flash is spawned at a socket that belongs to the pistol. We can take a look again at the skeleton. And here is our, now this is our foot. Pistol flash socket. There it is. It is attached to pistol ammo bone. And this is where we will spawn our flash. Note that the direction is important. It can be changed like this. The red arrow represents sort of forward direction. Back to the logic, to our main blueprint. We spawn the sound attached, then we make noise for the monsters to hear us. Then after slight delay, we spawn an empty shell at the socket named pistol ammo socket. Back to the skeleton, here's our pistol ammo socket, also attached to the same bone. However, it is in a different location and is pointing in a different direction. Back to the logic. Let's see our blueprint for the pistol shell. You can simply click this button, but it is located in pistol folder, pp pistol shell. There's nothing here really. Projectile component with initial speed of 400. We can see I've added this arrow to indicate the direction of our speed, our initial speed. So when we shoot, you can see those shells being spawned. When we reload, you can see the empty clip. Let's take a quick look at the empty clip. We do not need any velocity for this, simply false. So we have this static mesh here, and we have a delay. After 10 seconds we destroy the actor. This actually can be set here in the initial live spawn. So this is not really necessary. You can simply enter 10 here and delete this, but it's the same. I've noticed that we have tick enabled. This will be disabled in the back by default. Every time you create a blueprint, this will be enabled. However, if we don't need it, it is good to disable this. Even if we do not use the tick event, it still counts it. And if it is set to 0, which is the default value, it counts it every frame. This is used for some logic that requires checking something for every frame, for example. So this takes some processing power, even if we don't use it. And it is good to disable it. And all of the blueprints in the back has tick disabled. Well, supposedly. It appears that I have missed this one. So back to our main logic. Here in the noise node, you can see a number of options, the loudness and the maximum range. You can change this to your liking.